At URB-E, we needed to get prototypes built as quickly as possible and didn't have machining capabilities in-house. For this project, we relied on John at Millbury Machine Works to provide our first prototypes of the steering column plate, a critical component in our design. Knowing that John is a longtime SOLIDWORKS user, I knew we could rely on his company to provide the best service possible without worry of translating the part to a neutral file format. John had some time to take a look and sent us this message.
So hey guys, I want to give you an update on the SOLIDWORKS part you sent over this morning. First, thanks for being a new customer. We really look forward to working with you guys on a lot more projects in the future. So I've got some good news. Your parts just left final inspection and they're headed over to shipping. We're able to cut your 2-day turnaround requirement in half. Anyways, your parts are scheduled to be picked up by FedEx later this afternoon, and you should have them sometime tomorrow. So, by the way, thanks for sending me a SOLIDWORKS part. We use SOLIDWORKS for just about everything, and that includes CNC programming. When we get a SOLIDWORKS part, it really makes a difference in how quickly we can turn around a job. Hey, why don't I share with you some of the latest technology we use to get our jobs completed on time? Man, this shop can be really loud. Give me just a moment, and we can continue in my office. Let's begin by using the power of assemblies to create the setup drawings for a machine shop. My vise inventory is modeled in SOLIDWORKS, as well as the different jaws that I use in my shop. Here I'm positioning your part in my vise for the first setup on the shop floor. Now I really love the width mate, and I use this whenever possible because it guarantees that when you change the outside dimensions of your model, and trust me, you will, my assembly drawing and CNC programs automatically update to keep the part centered in the vise. So hey, next I'm going to calculate the size of the raw material that I need to order. I can do that with a single button click. I can check the prices online. Here I'm going to go to Online Metals, and I can go ahead and look up the exact size that I need. I can do this much quicker than my competition. So next, let's open up our shop drawing. It will now update to show and include your part. You know, our drawing has a bill of material, and it also has the machine 0 location. Also too, the Z-axis clearances for the tail-on grips, and of course finally a title block that will contain all the required setup information for the shop. You know, the integration of CAM with CAD reduces my cycle times, eliminates translation errors, and guarantees the fidelity of my customer's intellectual property. So here we can select the correct machine tool in SOLIDWORKS CAM. We can choose the proper tooling package for aluminum and select the custom post-processor that I wrote for my machine. A great benefit for the CNC programmer is to be able to quickly view detailed information about the post-processor and the G-code required for the controller. So let's select our part to be machined. And then after that, we're going to go ahead and associate the stock that we sized in SOLIDWORKS earlier to the stock manager in SOLIDWORKS CAM. So let's take a look at how SOLIDWORKS CAM handles a traditional CNC programming workflow. First, we're going to choose a tool to machine the fillet located at the edge of the through hole in the center of the part. Now, since this is our first tool path, we must identify the machining direction in Z, and then we can mouse pick the geometry to machine. First, we select the lower edge of the fillet, and next we select a face for the upper boundary for our operation. We can override, as you can see, the default feeds and speeds. We can select climb or conventional milling, turn on or off cutter compensation, and then choose the type of lead-in for our tool path. After generating our tool path, we can step through this a single block at a time if needed. Let's move on to interactive feature recognition, and this is where I begin to separate my shop from the rest of my competition. I can capture my customer's parametric design information in the form of intelligent machining features. Now once captured, I now understand everything about the geometry to be machined, including size, depth, radius, material, etc. With all this information, SOLIDWORKS CAM applies rules to automatically select the tools and the machining strategy to make the part. Now I've customized these rules to mirror my current workflows and processes. So the toolpath simulation shows the rough and finish operations generated by my machining rules. The tool and machining strategy you see were automatically selected based on these rules. A huge advantage is that my way of machining is evenly applied, automatically from job to job, providing consistency, saving time, and resulting in improved quality for my customers. So let's take a quick look at my rules-based machining database. Let's peek into the Features and Operations tab of the database. This is where 2.5-axis machining features, strategies, and operation-specific behavior is processed during both interactive and automatic feature recognition. And speaking of automatic feature recognition, let's use this powerful technology to program the remainder of your part. As an NC programmer, AFR is all about standardization and streamlining the programming process. By using rules-based machining, I can automate the repetitive and mundane work, which is about 80% of my daily process. This frees up my time to focus on what is important, and that is the 20% that's unique and requires my attention and more time to ensure a good product. Let's take a final look at our toolpath simulation. It took just 13 seconds to finish programming your part. The feeds and speeds, along with the axial and radial depth of cut for each feature, have been used hundreds of times in my shop, which means I can place my spindle and feed rate override pots at 100% and let her rip. No more backing off the feeds and speeds during the first few seconds of a cut and wondering if my tool is going to break. So we're ready to post-process and create the G-code that will run our machine. A large library of post-processors comes standard with SOLIDWORKS CAM. After posting, the G-code file is automatically opened in the SOLIDWORKS CAM NC editor. The specialized editor also allows backplotting of my G-code file. So let's revisit our shop drawing, and I want you to notice the title block has updated with all the relevant post information from my posting session just moments ago. Now, yesterday I told you that we were a SOLIDWORKS shop, and we utilize as many of their products as possible. And this also includes PDM Professional. As a new customer, I go to great lengths to protect and back up your design information within my PDM vault. If needed in the future, I can pick up exactly where we left off and even version different variations of your prototypes as they evolve over time.
Machine shops like Millbury Machine Works take advantage of SOLIDWORKS CAM today, as it is included with every seat of SOLIDWORKS. With advanced feature recognition and automatic tooling sequences, you can speed up your machine programming process tremendously. Keep watching this series to see how URB-E moved from concept to consumer, leveraging the SOLIDWORKS solution.